Yes, I need yes from the audience. Are you there? Guys, your active participation is highly appreciated. So, all of you am I audible to all of you? Am I clear to all of you? Yes or no? Nice. Someone is raising the hands. Can you just type yes in the chat box? All of you can type yes in the chat box. Yes. Now I think you are in line. Thank you so much for your great response. Now let's see. India is the third largest power producer in the world. If you look at the statistics of this, who is the first and second guys? Can anybody say who is the first and second? China is the first power producer in the world, and US obviously is the second highest power producer in the world. Obviously, the point here is what is the generation capacity of China and US and India? So there is no there is no point in feeling happy yes, at least we are being in third place like that. No, if you are taking the population into consideration, and if you are considering per capita power consumption in India compared to if you take US it is like a 4,154 trillion watt hours per year, and if you take China is almost double than US, but of course being the highest populated country in the world, so that is fine, but we are at a very lower stage. So with the help of this renewable energy sources, at least with respect to the population, we have to reach at least to the second place, and we are trying to be in the first place. Okay, so we wish within 4 to 5 years, India is going to be in the first place in terms of power producing. Okay, so these are the statistics. By looking at all these things, we understand the importance of renewable energy sources, the importance of solar and wind. So today our session is especially in terms of solar. So here it is mentioned like with an installed capacity greater than 137 gigawatts worldwide, and this is the old data, and additions more than 40 gigawatts in every year, more than 40 gigawatts. Solar PV technology has becoming an increasingly important energy supply option. So here we have to, we are just going in depth into the concept, guys. So solar PV plant. So solar is nothing but sunlight. Generally, we measure the solar sunlight in terms of irradiation. Okay, so the units for the sunlight, solar sunlight is we measure in terms of irradiation. Irradiation will be like a kilowatt hour, kilowatts, watts per meter square, and kilowatts per meter square, something like that. Okay, so watts per meter square is irradiation. The point is we have to understand in the solar PV plant technology, understanding of photovoltaic effect is will play the crucial role actually. So what do you mean by photovoltaic? Can anybody answer this question? Photovoltaic. See, generally the photovoltaic. What is photovoltaic? Any answers? Yes, actually, photovoltaic is the Greek word, guys. So, photo is nothing but photon. Photo is nothing but photon, and voltaic is nothing but voltage. So, the point is, photon is nothing but sunlight. Okay, sunlight, photon, all are same. When photovoltaic effect is nothing but when the photon is reaching on the semiconductor material, when the photon is reaching on the semiconductor material, so which creates an electron hole pair in the depletion region. So what happens? if you look at any typical solar cell, generally a typical solar cell will be like this. So typical solar cell is the formation of PN junction. So like we have this is like this. So we have like these are the P type, like we have all acceptor impurities and like this, which has the holes, and N type, which has the electrons in the N type layer like this. So what happens? This is the depletion region, we call it as. This is the depletion region which forms with the solar cell. Okay. So what happens here? Like when the solar, like when the photon is reaching on the cell, like here, this is a typical cell. Solar cell is a typical PN junction formation. Like a semiconductor material is going to dope with a P type and N type materials. P type materials are like a acceptor impurities. Generally, P type is a phosphorus, is the material we dope to the semiconductor material, and N type is a boron. Okay, so what happens here when the light, when the photon is reaching on the solar cell, when the photon is reaching on the solar cell, when it is reaching on P type, which this solar cell creates, depends upon the mm, photon energy. Depends upon the photon energy, what happens, which creates electron hole pairs. Okay, so wherever it is just moving on the solar cell, which creates electron hole pair. So when it is falling on the P type or N type, so when this electron hole pair creates, this will attract, this will like a positive and negative will get attract, and only it will give like a in the form of heat. So what is required for us here now? Like when this photon is reaching on the depletion region, depletion is forming with the semiconductor material. So what is our intention? When the photon is reaching on the depletion region, when electron hole pairs are creating in the depletion region, all the electrons will be accumulated in the N type layer and all the holes will be accumulated in the P type layer. So in the N type layer, all electrons will be accumulated, and in the P type layer, all the holes will accumulated. So when you are connecting with any load, so the electron travel will takes place from the N type to P type layer. That's how each cell will generate voltage, because I told you in the first class, like a cell is like a current is a flow of current, current is a flow of charge, and the voltage is the force. The electron is moving with the force, like what force electron is moving from valence band to the conduction band. So with that, a typical cell is going to generate some current and voltage. So here, this is what the photovoltaic effect. When photon is reaching on the semiconductor material, which creates the electron hole pair, all the electrons will be accumulated in the N-type layer, and all the holes will be accumulated in the P-type layer. So when you are connecting with any load, so the electron will flow from N-type to P-type. That's how each cell generate the current and voltage. That effect is called photovoltaic effect. So this is what the photovoltaic effect. When photons reaching on the semiconductor material, which makes the movement of electrons from valence band to the conduction band. That's how each cell generate voltage. So that process, we call it as a photovoltaic effect. Okay. So generally, who discovered this photovoltaic effect? Generally, this is discovered by Edmund Becquerel, is a scientist in the year of 1839. And this is used in first time in US in the year of 1954. That's what I told you, the principle of photovoltaic. This is very, very important. So if you want to understand for solar PV plant design, first we have to understand the how a typical cell is going to generate the voltage and current. That's how each cell will generate some power. It depends upon the cell efficiency. That we'll see now. Okay, so generally we have two types of solar plants, guys. We have like a solar PV and a solar thermal. So all these, whatever the pictures I'm showing here comes under solar PV. Like a solar PV is nothing but which converts light energy to electrical energy. Okay. And when it comes to the solar thermal operates based on the heat energy. Like in case of solar thermal, which converts heat energy to electrical energy. So generally, the countries like India, India is a semi-tropical country. We have balanced weather conditions with a great amount of irradiation values with a less temperature. So with these weather conditions, we come to a conclusion. The countries like India going with the solar PV is the most prominent solution than solar thermal, because coming to solar thermal, it has huge maintenance and it is not even economical, the countries like India. So by keeping that in view, most of the solar power, like almost all the solar plants comes under solar PV, not solar thermal. So now I just want to tell you like what are the components we are using in the solar PV? What is the overview of solar PV plant, guys? So let us see. If you look at this picture will make you understand in a simple way what are the components involved in the process of converting light energy to electrical energy. Okay, so as I told you, like whatever the light energy is like falling on the solar module which contains solar cell. Okay, module contains solar cell. So when sunlight is nothing but photon, sunlight is nothing but photon. When the photon is reaching on the solar module, which converts light energy to electrical energy. Here we have to understand one important point, guys. So the output, whatever the power generated by the solar cell, will be in the form of DC. That we have to understand. Whatever the power generated by the solar cell will be in the form of DC. So each module will have two terminals, like a positive terminal and a negative terminal. So what happens here? Like the output from the solar module will be in the form of DC. So whatever, because our connected grid or whatever the load we are connecting, so that is AC. But the power generating by the solar will be DC. So obviously, what we want here, we have to use one equipment which can convert the power from DC electricity into AC electricity. That is called inverter. So what we do here, we connect all the modules in series, that is called string. The strings are connected to the inverter. So here inverter is an equipment which converts DC electricity into AC electricity, guys. So broadly you can say like solar plant is divided into two parts. Solar plant is divided into two parts. Like up to inverter is like a DC side. Up to inverter we call it as the DC plant. And after inverter up to the evacuation point, we call it as a AC side. So inverter is a crucial equipment which converts DC electricity into AC electricity. So like this inverter will converts the AC output that will be given to the ACDB. We call it as AC distribution board. And in that you have the utility meter, or we can call this as a net meter. Okay, from there, if you are feeding power to the grid, if the grid is like 11 kV, then with the help of transformer, we are going to step up the voltage. That's where the power will be evacuated to the grid. So this is the process, like how the power is injecting that power to the load centers or grid. So now let us list down like what are the components involved in the solar plant. So guys, Can you just guess like what are the major components we use in the solar plant? I want answers from you. I have shown you the overview of solar plant, right? Like what are the major components we use in the solar plant? So the first and foremost is like a solar module. Yes, inverter, right? Only inverter. You can list of components. Okay. You are ignoring the first and foremost equipment in the solar plant. What is the crucial material? Like what is the costliest equipment in the solar plant? So the costliest equipment in the solar plant is solar cell. Nobody is giving answers like a solar cell. Somebody is giving now. Okay, solar cell is the VIP in the solar plant. Okay, so solar cell, module, and after the module, we have like a module mounting structure, inverter, and cables and ACDB. These are the various components. So let us list down like what are the components we use in the solar plant, and we'll just try to understand about each and every component. Like I'm going to make you understand. I'm going to give you in-depth knowledge about solar cell and solar module formation today. Okay, so here solar cell and solar module, module mounting structures and inverter, string combiner box, and DC and AC cables and ACDB metering yard. So depends upon the type of solar plant. If your solar plant is a rooftop solar plant, generally we don't use metering yard and string combiner box. The remaining all the components are used in the rooftop on-grid application. Okay, your on-grid and like if it is a ground mount megawatt scale application, we go with the metering yard. So here, now let us understand one by one component. Okay, so first the most important here in this one, solar cell and a module. Solar cell and module will be the costing of solar cell and module will be 40% of total plant. Solar cell and module cost will be 40% of total plant. So can anybody tell me, I have one question here, guys. Can anybody tell me 1 kilowatt solar plant, 1 kilowatt solar plant will generate how many units per day? 1 kilowatt solar plant will generate how many units per day? Yes. Yes. So I'm getting few answers. Of course, you're right. So I really appreciate your answers because I expected people give some odd answers, but so I came to know here like you people are very good in solar. Somebody is giving like a 12 units and someone is giving like a 24 units and all. See, common sense matters here, guys. So 1 unit, I'll just explain you. 1 unit is nothing but 1 unit is nothing but 1 kilowatt hour. Okay, so generally solar module generate the power from morning 8 a.m. to 4 p.m. So it is almost how many hours? Like 8 hours will be the generation. So generally what happens here, total 8 hours will not have the same generation. If you look at the solar generation, if the curve, your curve will be like this, reverse parabola. So this is like 8 a.m. and this is 4 p.m. So your solar generation will increase gradually. So you will have peak energy generation only in the afternoon, somewhere like a 1 p.m. to 2 p.m., something like that. So by keeping all these things in view, 1 kilowatt solar plant will generate 4 to 5 units, depends upon the irradiation values on the particular location. Okay, so the point here is again, if you want to understand like in terms of commercial terms like whether solar is suitable for domestic application, like domestic consumers or commercial consumers is a different discussion. So I don't want to get into that. So this is the basic question generally people will ask you in the interviews. So like 1 kilowatt solar plant. And I have one more question here. Like you should see the thing is any technology we have to understand in terms of technical and commercial. Unless until you understand the technology in terms of commercial, that is not full-fledged way of learning, because you are simply designing the system. But if you are designing the system with a heavy cost, then nobody will consider your design. Nobody consider your technology. So whatever the design you are giving, that should be like a techno commercial design. So for example, if you take like a 1 megawatt solar plant, that is costing around like now 3.2 CR will be the costing of 1 megawatt solar plant. So for 1 megawatt solar plant, this cell module will almost like a 40% of 3.2 will be somewhere around 1.3 to 1.4 CR will be the cost of only solar cell and module. So the remaining will be we call it the BOS, balance of supply. So obviously here, if you can optimize any equipment cost, majorly you have to optimize in terms of cell and module only. Okay, so now obviously we have to understand that equipment very clearly. So we will just go one by one, like what is cell and what is the formation of cell, how the cell is being formed from the semiconductor material to the module. Okay, I'll just take you through different stages involved in the solar cell formation, guys. So generally, if you look at this slide, like this is the semiconductor material powder. Okay, this mostly we use silicon semiconductor material, which is most economical, and like the availability of silicon semiconductor material is more. That's the reason we generally go with the silicon semiconductor material because of its band gap value also. Okay, so what we do here, um, we just do the process of silicon semiconductor material in the harness by adding wood chips, coal and all, and we burn this silicon dioxide semiconductor material at almost like a 1800 2000 degrees centigrade. Then it will form the ingots. Okay, see, generally what happens here is your normal silicon, whatever the extraction from the mining, you are getting the silicon semiconductor raw material. So that will be the, you have the purity of somewhere like a 75% or 80% purity of semiconductor material. But for the formation of cell, we need the purity of cell should be like a 99.999999 percentage, almost 100 percentage. So what we have to do now, we have to process the silicon semiconductor material to become highly efficient, highly pure semiconductor material. This raw material will be taken through various stages. So first, what happens? Like these are the different stages. I'll tell you. Like your silicon powder will become ingot. These ingots will be sliced into wafers, and this wafer will be doped with the wafer is a pure semiconductor material, 100 like a 99.999999% efficiency, purity. But only if you have semiconductor material, so that material cannot generate the power. So to generate the power, what is required? I told you like your solar cell is nothing but it's a PN junction. So we have to dope the semiconductor material with a P type and N type materials to when this light photon is reaching on the semiconductor. This is depletion region is formation with the semiconductor material. So when the photon is reaching on the semiconductor material, depletion region, which creates electron hole pair here in the depletion region, all the electrons will be accumulated in the N-type layer. and all the holes will be accumulated in the p-type layer. So to make this happen, we have to dope this semiconductor material with a p-type and n-type impurities, we call it as. So p-type impurity is the phosphorus, and n-type impurity is the boron. We use phosphorus and boron impurities we add to the semiconductor material, which makes the typical formation of solar cell. After that, what we do is here, you can see here, this is the white color one is a bus bar. So all the bus bars will be injected into the cells, so that whenever, like when these bus bars will help to flow the electrons from N type to P type. That's how a typical cell will generate power. So now let us see, like to get high purity of silicon semiconductor material, what are the stages involved? Okay, I'll just, because this is a very rare information, most of the people aren't aware here. So here polysilicon, ingots, wafer, solar cell and module. So here this poly, like whatever the raw material, silicon raw material, we are just making the process. That process we call it as a carbothermic process, carbothermic reduction process. So which would requires wood chips, coal and charcoal, guys. So in the mining, whatever the quartz material you are getting, this is a semiconductor material, silicon. So after the stage one, we'll get Mg silicon. Okay, so this is the first grade. In the first stage, we'll get the metallurgical grade silicon. Okay, this is the silicon raw material. So we'll just process the silicon material in the furnace. Like when you're making the process of 6.2 tons of silicon raw material, you will get 1 ton of metallurgical grade silicon. This is called black gold. This is the cost is equals to almost gold. But this metallurgical grade silicon purity also 99% only. We need the purity of 99.999999%. So to get that purity, again we'll process this metallurgical grade silicon through hydrochloric acid. When you are processing this metallurgical grade silicon through hydrochloric acid, you will get the the trichlorosilane, and the trichlorosilane is sent through the hydrogen gas. Then we get high purity of silicon semiconductor materials. Okay, so that this is like a stage one. Stage one, we have like when you are making this formation of silicon dioxide with a carbothermic reduction process, you will get metallurgical grade silicon and carbon monoxide will be the outcome in the stage one. And the stage two, the same metallurgical silicon to get high purity of semiconductor material. We are again processing with the hydrochloric acid, then we will get trichlorosilane. Then again, you are sending this trichlorosilane with the through hydrogen gas. Then we get high purity of silicon semiconductor ingots with a purity of 99.9999 and 99. This is what the purity is required to get the higher efficient cell. Okay, so these are the stages involves in the formation of highly pure semiconductor material. Now we extracted only semiconductor material. Now we have to dope the semiconductor material with a p-type and n-type. That's where it will form a typical solar cell. So now the point is, once you get the solar cell, we have to know like what are the different types of cells we have. Okay, what are the different types of cell technologies we have? If you look at like we have two types of cells. Guys, am I clear to all of you? Am I clear to all of you? Yes, thank you so much. So we have two types of cells, guys. You should understand one thing here is like within whatever the time is available for us. So I'm trying to give you more valuable information. I hope you understand my criteria. Okay, so please listen carefully, and whenever I ask you some questions, you please answer to those questions. Okay, so this is what max I can do my best in the given time. Okay. Yes, we have two types of solar cells. Like we have like a crystalline silicon cells and a thin film. So crystalline again, we have like a polycrystalline and a monocrystalline. And a thin film is like we have thin film cells are like manufactured with like a amorphous silicon. This is cadmium telluride and copper indium, gallium D selenoid and all. So when it compares to like every technology has its own specialty. But now the point is we have to understand like what is the, compared to polycrystalline, your monocrystalline cells are highly efficient. Monocrystalline cells are highly efficient. Obviously, as the monocrystalline cells are highly efficient, now in the present technology, we are using monocrystalline cells for the cell formation because of its higher efficiency. Okay, so let us see that like what are the different cells we have and here this is different cell like this is a mono. Generally here if you look at color wise, mono cells will be looking black, but there is no significance of black color like why it is in black. So there is no reason for that actually. Generally monocrystalline modules you will be looks in a black color and poly will be in the blue color. So in the latest present technology, all the cells we are going with a mono. Okay, because of higher cell efficiency, we are going to reduce the plant cell cost. So this is a thin film. See, generally this crystalline will be in the form of cells, but when it comes to thin film, like entire module will be a single cell. That's how your thin film. Okay, so there is no proper reason like a black can attract more sunlight. It's not like that because it depends upon your tilting angle of the module. Okay, so here now let us understand like what are the different types of solar modules we have. See, solar module is nothing but the formation of connection of cells in series formation. Generally, your cell is like this is a typical cell. This is a typical cell. This is a 60 cell module. So all the cells are connected in series. Why we are connecting in series generally here? Because we need voltage. Because all this power we are going to give it to the inverter. So obviously inverter requires voltage. So in the inverter, it is specifically mentioned the range, whatever the DC input voltage given to the inverter. Because of to get that voltage, all the cells are connected in series, and all the modules also connects in series. In such a way, we get the required DC input voltage to the inverter. Okay, so here, if you take any typical module, so all the cells are connected in series and it is provided with this is called bypass diode. So by the purpose of using bypass diodes is it will not allow the current flow in the reverse direction. Okay, bypass diode allow the current flow only in one direction. If any cell gets damaged, obviously all the current will flow towards the damaged cell, so which will be blocked by this bypass diode. So if you take any typical module, you will have like a three bypass diodes. Every module will have three bypass diodes with the one positive terminal and one negative terminal. So I'll just show you here how the cells are connected in series. I'm just trying to make you understand in a most practical way, guys. So because generally what happens when you look at any solar module, whatever the top layer, whatever the visible portion will be n-type layer. N-type layer is the negative, and below the cell will be p-type. P-type will be positive. So what I told now, This is like a, this is a negative. Top, it is connected. So from bottom again, it is connected to the top. Means the negative is connected to positive. Negative is connected to positive. Negative is connected to positive. Like that, all the cells are connected in series, 60 cells. That's how a typical module is formed. I hope you understood the module formation. Is it clear to all of you? All the modules are connected to inverter. Very simple. So see, this is a cells connected. This is how it is connected. Here, like I told you, like a top to bottom. Again, top to bottom. Again, this top to bottom. Like a top is the negative and the bottom is the positive. Like that, from every module will get one positive, one negative, and one positive. That is going to the output of the module. So let us see how the typical module looks like. So this is the module. Like what are the layers we have in the module? These are the cell array, you can say, like all 62 cells. Now the latest modules, we are going with the 144 cells. 144 cells. The cell type, we are going with a monoperk. And we are, after monoperk, we are going with the technology called TopCon technology, N-type TopCon technology. This is the monoperk is a monofacial. Monoperk is the monofacial, and this TopCon is the bifacial module. Bifacial modules in the sense like it will take the light energy from the front and back. So obviously, compared to monofacial, when you are going with the bifacial, you are getting almost like a 2 to 3% of energy output more. Okay, these are the different layers. This is encapsulant, like encapsulant will be provided in the top and bottom of the solar cell, guys. These are the different layers. I told you, like a top layer is a N-type layer and the bottom layer is a P-type layer. Okay, so this is a typical module we have here. Like I have an interesting point. Like this is a polycrystalline and a monocrystalline and a thin film. I told you, like thin film, the entire module will act as a single unit, thin film. And what is the advantage? Most of the majority power plants will be constructed with a polycrystalline or monocrystalline only, because the maintenance and all is used in case of thin film. Nowadays, people are going with the when you're installing the modules on the shades and all, we are going with the thin film cells. Okay, so I'll just tell you one interesting point here. Like if you look at evolution of solar module, like from 1954 to 2024, so what are the developments happened in the solar cell, guys? This is really an interesting point. In the 1954, like the efficiency of solar cell was 6%. The typical module rating was 20 watts. Okay, now you can see like from in the year of 2012, increase the cell efficiency to 15%, and the typical module capacity is was 200 watt peak was the module capacity. So the cell type we were using polycrystalline cells, and in the year of 2018, because of higher cell efficiency, so like efficiency is increased. See, when the cell efficiency increasing, the solar plant cost will reduce, obviously. So with an 18%, 18.7% of efficiency, we used to get the module rating like a 320 watt peak. The cell type we were using polycrystalline. Now the present technology, now we are using all because of cell efficiency. Like we have, I told you, like we are using like a monofacial and bifacial. So here, whatever the monoperks, perk is nothing but like a passivated emitter rare contact. Okay, so now the latest trend is we are going with the monoperk, monofacial and bifacial modules. And in case of monoperk, the cell efficiency is like a 21.3. And now we have the modules in the monoperk technology. We have the modules starting from like a 525 watt peak to almost like a 560 watt peak available in the monoperk. And when we are going with the bifacial, like your minimum um, module capacity is starting from 60 15 watt peak, and again almost the cell module capacity is available almost like a 720 watt peak modules also available in the market with the bifacial top con technology. Okay, this is the latest trend is going on in the solar module technology. So now if you go with any latest solar plants, you will see all the modules with the monoperk cells. And generally for the, especially for the rooftop applications, generally we go with the monoperk. And for the ground mount applications, we are going with the bifacial modules. So this is a brief about module technology and the evolution of modules, solar modules. So this is a typical back sheet of the module, guys. So generally, like this is the negative terminal and this is the positive terminal, which is given. Every module is given with almost like a zero point 0.6 meters length of cable, because all the modules shall be connected in series, and we should consider that as a string to connect to the inverter. For that, and this is called junction box. In the junction box, you have three bypass diodes. Okay, this is the back side of the module, guys. So this is all about solar cell and the solar module. So we have to, I'll just show you about the inverter. Generally, as I told you, inverter is the electronic device which converts AC electricity into DC electricity, guys. So we have different types of inverters. So the point is like it's a solar PV plant design concept is like a huge concept. So I'm just giving you the outlines about all the remaining components like a module mounting structure. So this is, we have like a fixed mounting system, tracker, and a seasonal tilt and all. So the next is we also use DC and AC cables, like whatever the power generated by the module in the form of DC, that shall be given to the inverter, and from inverter it is connected to ACDP, from ACDP to injection point. So up to inverter we use DC cables, and after inverter we are going with the AC cables. Okay, and this is a harness system. This plays a crucial role to connect from module to module and a module to inverter. So all this we are going to do with the um, cable harness system. Okay. So generally, typically you have like this is we call it as MC4 connectors. MC4 connectors means it is connected to the 4 square mm DC cable. Okay, this is the male connector and this is the female connectors. We generally use for the interconnection of cables from module to string to inverter. Okay. So these are the typical solar plants. This is a 5 megawatt solar plant, ground mount solar plant we call it as. So this is constructed designed by us only, and this is a typical rooftop solar plant. Looks like this. See here, like this is a typical ground mount. This is how the structure is um, installed and all. Okay, this is one single axis tracker. Generally, track compared to fixed mounting, we will get better generation with a tracker. Like we have single axis tracker and dual axis tracker. And now the latest trend is going on in the solar is like a floating solar, where you will get better generation because of the temperature conditions are very low in the floating solar. That's the reason people prefer to go with floating solar. Like these are the different types of solar installations, guys. Like this is a floating and this is a ground mount, rooftop, floating. All these we have different installation based on the client requirement. Here, this is one more interesting point. This is called the layout. Solar rooftop solar plant layout. This solar layout will be done by using the software called AutoCAD, and this is the layout. Like modeling is done in by using Google SketchUp software. Is like in the solar plant, we need to learn PVSys and Google SketchUp. PVSys is used for the energy simulation, and the Google SketchUp is used for the shadow analysis. Shadow analysis plays the major role in the solar plant because the solar module should not encounter with any shadows for to get the better energy generation. So this is done in AutoCAD, and this is done with Google SketchUp, guys. And you can see like this is how we generally do the modeling in Google SketchUp. So now this is what exactly I just want to give you insights about solar PV plant equipments and all. Now I would request Kavya to invite our today's guest, Mr. Sridhar. So over to Sridhar. Thank you so much. And Sridhar, please continue.
Hi, sir. Can you please turn on your video and audio, sir? Sridhar, sir, can you hear me? Madan, sir, could you please stop the slide share? Sridhar, sir, can you hear me? Sir, we can't hear you. Can you please?
Yeah, are you able to hear me?
Yes, yes, yes. Right. Now we can hear you. Yes.
Yes.
Yeah. So guys, we first I would like to thank Mr. Madan Mohan sir for his wonderful insights on solar PV plant design. I think we have understood the basics of solar and what are the softwares that are involved in solar PV plant design. Okay, thank you, sir. And I would like to invite our guest speaker, Mr. K. Sridhara Babu, CEO of Ecorin Energy, who has 22 years of total experience in the electrical field, in which 18 years of expertise into renewable energies with Cleantech Solar, Lanco, and First Solar companies. We are very honored to have you, sir. We welcome you.
Thanks. Thanks, Kavya, for the nice
Thanks.
introduction.
Sir, off to you. You can go ahead. You can, I will be just.
Yeah. So, good evening, everybody. And I was completely listening to Madan sir's lecture, and he has given a complete insight of what the solar energy is and what is that which is required right now. So for the people or the students who are going to, so lead their career in solar energy. So I do not want to get into so the core technical details which Madan has already explained to you. I just wanted to give a glimpse of so what are the various opportunities that we have in solar energy. Uh, but so prior to so even get into that, so first of all, you guys definitely will ask me, sir, so why we need to get into solar energy. So what is the potential that it has got even in the country or even in outside India? So I just wanted to give a very brief of what exactly so the share of solar energy is. I hope you guys are able to see my screen. Are you
No,
guys able
sir.
to see? Yeah,
No,
see my
sir, we are
screen.
not able to see your screen at the moment. There's some, yeah.
Now it's
Now it's partially visible, sir. So would you like to help me with the screen share?
Yeah, I think that is better. I'll just
Yeah.
stop sharing.
Yes, sir. Let me do the screen share. Give
Yeah,
me a
please.
moment. Just a moment, sir.
Yeah.
I guess now the screen is visible. Is the screen visible, guys? Okay. Sorry, is the screen visible? Guys, students?
Yeah, now it is.
Kavya's slideshow,
Yeah.
please.
Yeah,
Yes, yes.
now is
Yes,
it
it
okay?
is. It is visible. Can you go to the next slide? So
Yes,
yeah,
sir. Yeah.
yes. So I mean, why we need to get into this solar energy, or I can say, I mean, solar energy is a part of renewable energy, where so it doesn't require any coal or gas as a fuel, so to produce the electricity. And the basics of the solar energy, so how exactly a photovoltaic, so cell works, which was already given by Madan sir. So if you see the Indian, so the energy mix, let us say India is actually producing almost like, so it has got an installed capacity of 4.45 lakh megawatt. So of which, so almost like 45% is coming from the renewable energy mix, which is like wind, solar, hydro, and of which so almost like 33% is coming from solar. So if you see, 33% of the entire energy mix you are getting mostly from wind and solar. And again, if you go to the next slide, so can you go to the next slide, Kavya? Even in the renewable energy mix, so the dominating as on today is solar. So there are huge opportunities which we have got for solar. If you can see, almost like, so out of 1.45 megawatt, solar is almost occupying a space of 58 percentage, and it is keep growing. So the reason for people going for solar energy or solar power plant installation is, number one, it is modular, and at the same time, so you can expand from a small capacity, means you can keep the solar plant on the roof of your house. And so you can also install the solar plant in very big farms, where you have seen several photographs of rooftops, as well as so the bigger ground mount projects. And this is the place where so the solar energy is so becoming more popular now. And can you go to the next slide? If you go to a solar power plant, so basically what are the various steps that are involved, in going ahead with a solar power plant? So first, what you have to do is you have to identify the location where you wanted to have your solar power plant. You have to identify the location, and in that particular location, you have to so collect the solar data, which is like so how much is so that the temperature, how much is the solar insolation in that area, and what is likely to be the wind speed. So all these parameters you will collect. Then afterwards, you will go ahead with solar resource assessment. And then so once you have the solar potential, if you know in that particular area, then you are going to so find out so whether the area is feasible to construct the solar plant or not. So as you have seen several photographs where the solar plants are mounted on a module mounting structure, and which are spread so across so hundreds and thousands of acres. So how far that land is from so your grid substation. So these are all a part of your so the site feasibility study, or I can say solar site assessment. So and then afterwards you have to go for land acquisition. And once the land acquisition is done, then you will start working on the civil foundations. We have seen just now so the various types of mounting structures. It is a fixed steel structure, or a tracker structure. You will have to select which module that you are going to use. You have to select which inverter is you are going to use. Various components you have to select. You have to do the design for all these components to build a solar plant. And then you have to construct a 33 kV switch yard, and you have to construct a transmission line. And then next slide please, you have to construct a big pooling substation. So and then you have to construct a transmission lines, I mean, which are like 220 kV or 132 kV. And you have to get all the regulatory approvals to commission the plant. See, the reason why I am explaining all these so steps is, every step so has got so the requirement of manpower, which are nothing but solar engineer. As Madan rightly mentioned, so the entire solar plant or a solar system is divided in two different components. One is like you have a DC section, or I can say sections. One is a DC section, and another one is a AC section. In DC section, so that solar engineers are required to design the DC solar power plant. And AC side, so you need the expertise. So to design, so the transformer, to design auxiliary transformers, circuit breakers, current transformer, potential transformer, as well as the metering system. So at power transformer, inverter duty transformer. So these are all nothing but the various components, and every component has got an industry. So there are several industries which are existing. So it is not that so when you are working for a solar plant, you need to focus on only solar energy. No, solar energy is, of course, it's a part of an entire core electrical engineering. The concept of electrical engineering applies even for solar power plant also. The one which is new for you is only the DC side, where how the solar energy is converting into a DC energy, and then from the inverter onwards, it is completely wherever, whatever the source that you consider, it is the same. That we call as power evacuation system, the entire power evacuation system. So be it so solar, be it thermal, be it so a wind, all are common. So every component, or at every stage, you require the people to be an expertise in that particular area, and to build and to achieve that particular so construction of the solar power plant. So the opportunities are plenty, and every area has got a requirement in the industry. So you need the people so just to work only on the PV system, which we call as solar, which we call as solar resource assessment. So, and all these concepts, of course, HAI will teach you guys. Now, so the opportunities wise, so whatever the line items that I'm considering, so there is an opportunity for each and everybody to excel in that particular line item. So these are nothing but the various steps to construct a solar power plant, but every step has got an industry, or so which includes both designing as well as construction, as well as operation and maintenance. Every line item has got its own industry. So there are several people which are required, so in this solar industry. So just so the final buzzword which I would like to tell you guys is the opportunities are so plenty, and because the solar energy and solar field is growing in the country. So now so solar, earlier we started when we work, it is like kilowatt, so now we are seeing megawatts, and then as well as gigawatts in the country. So and it is keep growing. So this is what I just wanted to share my thoughts on the opportunities that you have got in solar energy.
Thank you, sir. These were great insights. Now I would like to ask Madan sir to give the announcement for the day. I'll be stopping the screen share.
Thank you, Mr. Sridhar Garu. Thanks for your
Thank
great
you. Thank
insight
you,
about
Sridhar sir.
opportunities in
sir.
solar PV plant. So, guys, as we informed you earlier, like today we have a great announcement. We are going to start our internship on solar PV plant design from September 16th. This internship would be more useful in terms of learnings as per the industry requirement, and this will be more useful for third year, final years, and this will be useful for everyone. So whoever has to get expertise in solar domain, so those people can join with our internship program, which is going to start from 16th September. Okay, so I'll just brief you like what are the contents. Yes, this internship would be online, and the contents in the internship will be given like a step-by-step procedure for the solar PV plant design with all equipment selection and sizing calculation in detail. And we will also make you expert in software called PVSYST, which is to be used for the energy generation reports. And Google SketchUp is a software is used for the shadow analysis. In addition, we are also going to make you understand AutoCAD software for the preparation of single line diagrams and layouts. So this will be the outcome of internship. Guys, I want to tell you one thing here. This internship is not like whatever you are doing in your online for 250 rupees or 300 rupees. So this internship is purely industry-based internship, and this knowledge will definitely leads to get a job into the industry. So that is by keeping that in view, we are just announcing this internship, and whoever wants to get expertise in the solar domain, so those can register us with this internship. And the cost for this internship, we are going to charge 4,000 rupees for 4 weeks. 1 month internship we are going to give, and we are charging 4,000 rupees. So here we have the announcement I told you, like, see, whoever is going to, what about you? Like, 4,000 rupees is a reasonable amount, or it's okay? What do you say? 4K is a reasonable amount or not? I just want to know from you, like, what is your see, every day the internship will be in the evening, same like now 6:30 to 8. Okay, the timings will be every day, it will be like a 1.5 hour. Okay, it is available online and offline. Whoever is in Hyderabad, so you can directly come to our place. So you can go through the class offline, as well as it is going to and all the classes will be the live classes. So it's not like we are not going to give you any recording sessions, like people are giving some recording sessions, and just you go through the recordings, and after completion of recordings you will get the certificate. It's not like that. So we are, all the sessions will be the live sessions. Okay, and after completion of internship we will also provide you a site visit. So this is purely a knowledge-based internship, I'm telling you. So interested candidates. So cost, I told you 4,000 rupees, and I'm going to give you the announcement. Whoever register the internship today, so we are going to give you 50% discount straight away. So the internship will be 1 month. So interested candidates, please scan this QR code and complete the process. And whoever is going to pay the amount today, so for those candidates only the 50% discount is applicable, guys. So you can pay it later also, but for whoever is paying from tomorrow, you have to pay 4,000 rupees. So I'll give you 1 minute
Madan
time.
sir, thank you, thank you. I'll just give a note. Guys, the link will stop receiving the payments from from night 12 o'clock. So as mentioned, the link will be open till night 12 o'clock. Okay. And you can take a screenshot of the respective QR code given on the screen, and then click on the QR for your registration. Okay. Anybody who is facing the difficulty, we will also put the respective form link on our community. You can try registering from there if you have any query, or do ping to our team. Will help you out in that aspect. The timings of internship will be told. It will be according to your considerable timings based upon
It will
your
be
college.
in the evening from 6:30 to 8.
Yes, we do provide 1 day site visit, Mohan. Yeah, we'll be sharing our feedback.
And after
Thank you guys
completion of
for very much.
after completion of internship, we will give you the certificate.
Yes. It is on September 16th, Charan. It will be for 1 month, Sandeep. No, we will not provide any job opportunities after the internship. That is basically an practical oriented internship for pursuing candidates.
So whoever is going to
Yes,
make
we
the
do
payment
provide
today,
AutoCAD software for drawing the SLD. That will be a demo version for student Venkat Teja. The payment
guys,
for today's cost is 2,000, guys. Sorry, sir. Please continue.
see, you can scan the QR code, and today's cost is 2,000 rupees. And if you are paying from tomorrow, it will be 4,000 rupees. We are just, as you have connected to this free masterclass, we are giving 50% discount to all the participants. So course is available online and offline. I think we have given all the details, guys. we'll give you 1 minute time to scan the QR
If
code.
people are looking for an offline class, I mean offline session, that will be at located at SR Nagar near to Amirpet, Karthik, at our organization. Yes, it will be the respective internship program will be in form of solar PV plant design. Arun, this might not help you out within this. If you want to just upgrade your knowledge, you can go ahead, okay? Arun will contact you. You please ping us on our number. Maybe I can share you.
Team,
Sorry,
please guide
Arvind,
them.
the
Please
1,000
guide
is
them like how to make the payment. I think they are facing some issue.
no. They're not facing any issue about it. Guys, please scan the QR code and you'll get a link. Open the link, start filling your details, and go for the payment details. Then you can do it by your phone pay or Google Pay, anything by doing it bank transfer. Okay, before everybody goes on, maybe this QR code will be shared on our community in terms of announcement. Manjunath, could you please do that favor? And this will be also be shared on the chat box if required. Kavya, please do that help. So we'll
And
go
one
on.
more option, is available for this
Sure, sure.
internship is we are going to provide lifetime recordings for this internship. Internship will start on 16th September this month. So it's a Monday. And the duration of the internship will be 1 month. So now, Bhavya, I think we can attend the questions.
Guys, please take a screenshot of this. I'll be
Course fee
sharing.
for today is 2000 rupees. Please note down. That is applicable only for today. The offer is applicable only for today, guys. Thank you so much. You can start questions. Thank you.
So 1 minute. The screen. Please take a screenshot of this particular scanner and then you can do the payment. And then all the details regarding the internship will also be given a chat box. Okay. Now we will be taking up the questions. I'll be stopping the screen.
Yeah. So guys, the first question goes on with Mahesh. Babu, you can unmute and speak, Mahesh. Okay, there's a question before Mahesh unmutes. Sir, why only 4 to 5 units for 1 kilowatt?
See, that's what because the solar generation will be from morning 8 to evening 4 p.m. week. The light is available, guys. Okay, so the available number of hours will be 8 hours. So I told you the gradual like a solar generation will be gradually increasing and decreasing. It's like a reverse parabolic. So you will have peak generation only in the afternoon 1 to 2 p.m. So by considering all these parameters, so each 1 kilowatt plant can generate only 4 to 5 units in a day. 1 unit is equals to 1 kilowatt hour. Okay. 1 kilowatt hour means 1 kilowatt of power is generating for the duration of 1 hour. We consider that as 1 unit.
Okay. Tarun, you can speak up.
Good evening, sir. Hello.
Yeah,
Yes,
good
Tarun,
evening.
you're audible.
Good
You're
evening, Mr.
audible.
Tarun.
Sridhar, sir, we
Yes,
are
sir.
expecting you also onto the questionnaire. Can you please unmute yourself?
Yes,
I can also answer.
yes,
Thank you.
sir. I have two questions, sir. One is a scenario that. Hello.
Yes, continue.
Yes, sir. Sir, we have. Sir, if we install a solar plant on our roof pad,
Okay.
it will be more. It will be more cost, sir. It is about if we install a 1 kilowatt solar on our roof, it will be charged up to an 20,000 like that, sir.
No, it will be 50 to 60,000 rupees.
Okay, sir. If we install that much plant on our roof, hmm, sir,
Okay.
if that cost we can buy an EB power by the by our government up to 10 to 15 years, sir. Almost 20 years also. In which case we can consider solar as that much economic to us.
See,
Okay,
actually,
what was your second? EV
See,
power, he said, sir.
okay.
Yes, ma'am. EB power, ma'am.
Sridhar Garu, I
Okay,
think
so the compare.
Yeah.
So his question is like how solar is reliable if I compare it with EV.
no. See, actually
See,
for
basically, so EB power is the one which generally we will. I mean, if you see today's, so the EB power per unit is, so 6 rupees, so, and, so the once we install solar, it will work for 25 years. Generally, if we consider the, life cycle cost, what we call as, so a life cycle cost of any solar power plant, so your EB never will be 6 rupees throughout your 25 years. But once you install the solar power plant, so the units it produces, and so on a longer run, so if you take the cost of the investment that you are doing right now for solar, and the cost that you are going to incur by using EB power, so always solar is much, much, much beneficial, because the cost of investment at the same time, its running cost is also less. EB never will be 6 rupees throughout your life, so you also know that, each and every, like, so once in a 2 years, 3 years, the EB bill is keep increasing, right? So per kilowatt charges are keep increasing. Okay. So that is what, always a solar, if you take in a life cycle cost basis, solar is always much beneficial than EP power.
Oh, yes, sir. Okay, sir. Do the installed panels will give the same power? Do they lifespan, sir?
See,
no, there is a degradation factor. Every
yes.
year that is the power output will be reduced with a 0.4% or 0.3%. Depends upon the module manufacturer.
Okay, sir. I have two more questions, sir. Please.
Okay. Yeah, it's okay. You can.
Yes, sir. Sir, I know based on the load and the usage, we can increase the production, sir.
Okay.
I just want to know what is the
మీరు
minimum.
ఒకవేళ తెలుగు అయితే యూ కెన్ స్పీక్ ఇన్ తెలుగు ఇఫ్ యు ఆర్ నాట్
Yeah, okay, sir.
కంఫర్టబుల్ ఇన్ ఇంగ్లీష్.
ఓకే సార్. ఇప్పుడు మనము ఒక ఒక ఎంతైతే మినిమం పవర్ ఎంత ప్రొడ్యూస్ చేయగలుగుతామో మాక్సిమం పవర్ నీడ్ కన్నా ఎక్కువగా కానీ మనం మాక్సిమం పవర్ ఎంత జనరేట్ చేయగలుగుతాం సార్?
See, it's not like that. Actually, solar installed capacity depends on your number of units consumption per month.
ఎస్ సార్.
Okay, based on the number of units power consumption and based on the space available on the roof,
ఎస్
we
సార్.
will decide what should be the installed capacity at your location.
No sir, generally what is the minimum energy that produced by a solar panel, sir?
That's what I'm telling. 1 kilowatt solar plant will generate 4 to 5 units in a day. You can calculate in that segment, in that
Yes
prospect.
sir. Yes, sir. Can we integrate the energy sources, sir, like solar, EB and wind?
EV and
all-
solar would take little more
No,
time,
that is different. Okay.
Tarun. Yeah,
Yes.
maybe his concept of what they do in college, where they have an EV vehicle with an solar on the top.
Yes
The
ma'am.
rate of
Yes ma'am.
conversion would be very minimal, and coming to implementation would really take longer time, where the efficiency of the panel should be much increased. Okay, Tarun,
Yes.
considering the time constraint, we'll go
Okay,
for
thank
the
you ma'am.
next
Thank you.
questions. Thank you,
Thank you,
please.
sir. Thank you.
Next.
Giri Nayak, can you please unmute and speak up? Lalasa, you can ask your question.
Good evening, sir.
Hi, good evening.
So just now you have said for a solar cost
Your voice is
and
not.
hello, sir.
Yes, tell me.
So you have said for a solar cell there will be more cost. 40% of cost will be goes to the solar cell only.
Yes.
And in a monofacial and bifacial, compared monofacial is best.
No. See, bifacial will have higher energy generation compared to monofacial. That's where we are going with bifacial modules mostly nowadays. Like latest trend is going with the bifacial top concept technology. Am I clear your
Okay.
question?
Hope you answered your question. Girinayak, you can unmute and speak up. Vishwa, you can unmute and speak up.
Hello, sir, I'm audible.
Yes, yes, you're audible. Tell
Yes,
me.
yes, Vishwa.
Sir. Sir, why the solar panels are tilted at an angle 45 degrees?
Sorry, solar plants?
Solar
At an
panels are
angle
at an angle 45 degrees.
of 45
No.
degrees
Actually, it's
tilt.
not like a 45 degrees or 30 degrees. It depends upon the latitude of the location, at which angle you are receiving highest amount of irradiation from the
Irradiation.
module.
Okay, sir.
Anwar, you
That
can
the tilting angle will be
speak up.
decided. No fixed tilting angle.
Thanks, Vishwa, for your question. Anwar, you can ask a question. Before Anwar asks a question, there is question from Sharun asking, can we install solar on our roof without government electrical meter?
You can that in that case you have to go with the off-grid installation. So you have to set up a battery backup and all. That will be more costly than going with net meter. So you can nowadays like a Pradhan Mantri Har Ghar Surya scheme will be most prominent solar scheme. You can utilize that benefits. That will be most economical than going with normal. Okay.
Okay, there's a question from Maunika, how to find weather data, sir? Okay. Like, I think you have answered with respect to meteornom data, sir. So she's asking about weather data. Would you like to answer that?
Sorry, can I come again with the question?
Weather data, sir. Weather data. How do we find weather data?
Weather data will be taken. There are different sources to extract the weather data, like a meteornom or NASA and a PVGIS. There are different sources to extract the data. But generally, when you are working on PVCist, we'll take weather data from meteornom or NASA. These are the most prominent websites to get the data.
Okay, there's a question from Pratyusha. Can we develop a non-electrical device for tracking the movement of sun for solar panels? Is it possible? Then how is it? Can you explain me with this question? Okay, she's asking about tracker.
He's asking about tracker, but without using electric power.
Yeah.
As on today, we
Maybe
don't
we
have
can
much
use the mechanical power as in just like how we do it in
but
EVs. That is one
as
thing
on
we can do it.
as on today, we have no such kind of installations. Maybe we have to work on that. It's a good
Thought
suggestion.
process. Yeah. Thanks, Lukesha. Yes. Mohan, you can unmute and speak up.
Good evening, sir.
Hi, good evening.
Sir, actually, in a solar power plant, normally the output of the solars will be not constant, no, sir.
Sorry.
The output of the solar power plant will not be constant every time, no, sir.
Correct.
Okay.
In a solar power plant, normally after the solar power plant's inverter and after inverter, the DC supply will go to transformer, no, sir.
Sorry. After inverter, power will be converted to AC.
Yes, sir. Actually, yes, sir. Absolutely. After inverter, AC it will be converted to AC. So that AC power will go to the transformer to step up the voltage, no, sir.
Yes.
So every time throughout the day, the voltage will not be constant, no, sir, from the solar panels like that.
Okay.
Totally depends upon the solar energy. So for transformer, the primary side, the voltage should be constant, no, sir, because it is a rated. There will be some rated values for transformer, no, sir. So
Yes.
how that be maintained constant for the
See,
transformer
actually,
value?
whatever the DC input voltage given by the modules, okay, irrespective, there is a voltage called MPPT voltage range for the inverter. So when the voltage given to the inverter within the MPPT voltage range, then that voltage, DC voltage will be converted to AC voltage and your AC output voltage will be like a plus or minus within the range of plus or minus 10%. So that is okay to give that voltage to the inverter, because all the like that is an acceptable voltage range for the transformer.
But throughout the day, it will be not the same, no, sir. Means including that plus or minus 10%.
So throughout the day, that voltage is not constant. Even though in the normal conditions also, voltage will be vary based on the load conditions. Okay, so all equipments are designed to withstand with a plus or minus of 10% voltage range.
Okay, sir. So in normal condition, means in night time or in a non-summer time, so the transformer and the whole plant will be shut down, sir. Means in off condition. Will that be in off condition?
No, no, I didn't get your question. Bhavya, can you repeat that?
Sorry. Pawan, can you please repeat your question?
Sir, actually in something like night time, sir. When there
Okay.
is no presence of sun, the whole plant, will that be in working condition or in the off
No,
condition, sir?
no. During night condition, there'll be no generation in the plant.
So the transformer will get charged during morning time and will be off during night time, sir.
Obviously, when there is no power output, power generation, your transformer will be off.
Okay. Thanks, Mohan, for your question. We'll go on with the next people. Many of them are waiting. You, Shankar, you can unmute and speak up. Vasu, you can unmute and speak up.
Hello, sir. Good evening, sir.
Hi, good evening, Vasu.
This is Ivashankar, sir.
Hi, Yoshankar, tell me.
Sir, I have a doubt. What are the kind of job we can get from if we are good at solar? What are the kind of job we can get, sir?
See, there are different roles, like you can work as a design engineer, and you can work as a detail engineer, and you can work as a procurement engineer and a site engineer
Business development
and
is
business
also a great.
development engineer and a commissioning engineer. Okay, so and you can also get a jobs into product manufacturing side, like a cell manufacturing, module manufacturing, and inverter manufacturing units. And if you have good knowledge, in addition with the solar, if you have good knowledge in substation design and all, then that is a difference, because every solar plant will have a substation. So there is a huge set of scopes. So for that, you
Maybe
need
we will
to
talk about.
for that you need to gain great amount of knowledge, in-depth knowledge into each and every component. Okay, for that our internship will be
Right.
useful for you. Okay.
Yes, sir. Maybe we can answer them in detail again about the opportunities in our class day 5. So,
Yeah.
Shankar, I request you
So
to
you
join
please
that day
connect
to
on
understand the
day
opportunities
5
for
on
electrical engineering.
employability skills. On that day, will be your answer will be clear, very clearly.
Vasu, you can unmute and speak up. Somnath, I've requested you to unmute.
Hello.
Yeah, Vasu, please
Good evening,
continue.
sir. Hello.
Good evening.
సార్ మీరు చెప్పారు కదా సార్ ఇప్పుడు 60 మాడ్యూల్స్. హలో.
Yeah,
Yes,
yeah,
yes.
please continue.
మీరు ఇందాక చెప్పారు కదా సార్ సమ్ ఎగ్జాంపుల్ తీసుకొని 60 సోలార్ మాడ్యూల్స్ సిరీస్ లో కనెక్ట్ చేస్తామని చెప్పారు కదా సార్.
మాడ్యూల్స్ కాదు, సెల్స్, 60 సెల్స్.
సెల్స్ ఇప్పుడు ఒక గంటలో మనకి ఏదైనా ఫాల్ట్ వచ్చిందంటే ఎలా ఐడెంటిఫై చేస్తాం సార్? సిరీస్ లో ఉండడం వల్ల మనకి పర్టికులర్ తెలియదు అనుకుంటా.
See, the point is we will have a monitoring system. We use SCADA in every solar plant. Okay, so the SCADA will identify each module level monitoring is there, each string level monitoring is there. So any one string is not giving proper output. So people identify that string. There is some problem in this string. So then they will go one by one module. That's how maintenance people identify the problem.
Thank you, Vasu, for your question. Somnath, you can ask your question.
Good evening, sir.
Good evening, Somnath.
How many voltage in Zener diode or silicon diode through the current flow?
What is the voltage of an Zener diode rating is what you're asking. Somnath, is the
Actually,
question?
Yes.
I'm not clear with your
How
question.
many-
Somnath, your voice is not clear. Can you put your question? I'll surely answer your question. Sorry, considering the time constraint. Your voice is not clear, Andy. Girinayak, you can unmute and speak up.
Hello, good evening, sir.
Yes, good. Please make your internet stable because your voice is not audible clearly. Okay. I'm. This is to everyone. Okay. Yes. Please ask a question.
Nayak,
Sir,
your
in India, the
yeah.
majority of power production is from thermal power plants, sir. If we install, sir, am I audible, sir?
Yes. Yes. Continue.
The majority of power production is from thermal power plants, sir. Why government doesn't taking any action like activities? If we install more solar thermal power plants, the power production will be more at reasonable cost, sir. What is your comment about this?
Compared to solar thermal, going with solar PV will be the most prominent solution for the Indian conditions. That's the reason Indian government is encouraging solar PV plants instead of going with solar thermal.
Not solar thermal, sir. Yeah, thermal power, steam power station, sir.
Thermal
Instead
power
of
plants.
steam
The
power.
problem with the thermal power plants, which has more carbon emissions into the environment. So to control the pollution, to control the carbon emissions into the environment, Government of India is encouraging renewable energy sources. That's where our topic today is.
Okay, sir. All PV cells are connected in series, sir. What if one cell is damaged? The total PV cells are going to damage or not, sir?
No, it's
No.
not going to damage. So that one particular cell will be replaced with a healthy cell. That's it.
Thanks,
Thank you.
Nayak, for your
That's where
question.
bypass diodes plays the major role.
Thank you, sir.
Ram Babu, can you please ask your question?
Sir, good evening, sir.
Hi, good evening, Andy.
Sir, each cell, how many voltage produced, sir, in a PV model?
Each cell.
Each cell,
On a PV model, how much voltage is produced?
it depends upon the cell efficiency. Typically, your cell voltage will be like a 0.5 volts to 0.65 volts.
Okay. What is the insolation in solar, sir?
Sorry?
Insolation. What is meant by insolation?
Installation in the sense,
No,
keeping
he's
the
asking
module.
about insolation.
sir.
Insolation. Irradiation.
Insolation.
Right.
Insolation is nothing but irradiation. Sun,
Yeah,
photon energy.
Radiation.
Yes.
సార్ నేను ఏంటంటే వేరే ఒక క్వశ్చన్ చూశాను. ఇన్సులేషన్ వాల్యూ ఇచ్చాడు, సైజ్ ఇచ్చాడు, ప్యానల్ సైజ్.
ఓకే.
ఓకేనా? ప్లస్ ఎఫిషియన్సీ అనేది ఇప్పుడు మనం ప్లాట్ పెట్టాం సార్. పెట్టినప్పుడు దాని యొక్క ఎఫిషియన్సీ ఎలా ఫైండ్ అవుట్ చేస్తాం మనం? జనరల్ గా యూనిట్స్ పర్ డేకి వచ్చేసరికి ఇప్పుడు యాక్చువల్లీ మా దగ్గర 150 కిలోవాట్ ప్లాంట్ ఉంది సార్ మేడం. అది పర్ డేకి వచ్చేసరికి ఏంటంటే 500 యూనిట్స్ వస్తుంది. అంటే యూనిట్స్ బేస్ చేసుకొని మనం ఎఫిషియన్సీ ఫైండ్ అవుట్ చేయకుండా జనరల్ గా మనం ఇప్పుడు యూనిట్స్ ప్రొడ్యూస్డ్ యూనిట్స్ బట్టి మనం ఎఫిషియన్సీ ఫైండ్ అవుట్ చేయకుండా, ఇప్పుడు ఎగ్జాంపుల్ ఒక మోటార్ ఉంది, ఆ మోటార్ కి ఎఫిషియన్సీ మనం ఫైండ్ చేయాలంటే
ఇక్కడ అలాగా సెల్ ఎఫిషియన్సీ ఇస్తారు సార్. మొత్తం మాడ్యూల్ ఎఫిషియన్సీ మీ మాడ్యూల్ 16 to 20% లోపల ఉంటుంది సార్. ఒకసారి చెక్ చేసుకుంటే సరిపోతుంది మీరు. ఓకే, మీరు ప్లాంట్ ఎఫిషియన్సీని సెల్ ఎఫిషియన్సీని కంపేర్ చేయలేరు సార్ అక్కడ. మీ యూనిట్
సెల్ ఎఫిషియన్సీ కాదు మేడం, మామూలుగా ఈచ్ సెల్ వోల్టేజ్ 0.5 వోల్ట్. ఓకేనా సార్ చెప్పారు. ఇన్సులేషన్ అనేది ఓకే. అయితే ఒక ప్లాంట్ యొక్క ఎఫిషియన్సీ అనేది మనం ఎలా ఫైండ్ అవుట్ చేస్తాం?
The plant efficiency depends on your cell efficiency only, module efficiency, whatever the module you are considering. Okay. So, and that is not actually, plant will not be considered the efficiency. It's a performance ratio. There is a PR value will be there for every plant.
అంటే సార్ బిఫోర్ మీరు క్లాస్ వచ్చేసి మనకి 2004 2019 కు మీరు మోడల్స్ ఇచ్చారు కదా, దాంట్లో వచ్చి ఎఫిషియన్సీ ఇచ్చారు కదా.
See, that efficiency based on like how much irradiation is reaching on the module surface, and what is the output from the module based on efficiency is nothing but output to the input, right?
ఓకే. అండ్
ఎంత ఇరేడియేషన్
అంటే
ఉంది అండ్ ఎంత అవుట్పుట్ వస్తుంది అనే దాని మీద డిపెండ్ అయి ఉంటుంది కదా సార్.
Yes.
సో
So now
ఇరేడియేషన్
అదే
because of
మాకేంటంటే డిపెండ్ ఆన్ ది వెదర్ ఫస్ట్ ఆఫ్ ఆల్.
కరెక్ట్ వెదర్ అని అనలేం సార్, అక్కడ ఉన్న
conversion
రేట్.
okay, conversion rate.
ఓకే.
So 6% అంటే
కన్వర్షన్ రేట్.
6% అంటే మీకు 1000 watts per meter square irradiation వచ్చినప్పుడు only 6% of 1000 watts per meter square is converted to electrical energy. అప్పుడు
ఓకే.
now it is converted to 23-24%. Obviously, because of the conversion rate is very high, your cell cost is going up.
జనరేషన్ అకౌంట్. యా
Okay.
ఓకే.
థ్యాంక్
సార్
యూ.
ఇంకోటి డౌట్, ఇప్పుడు మనకి సోలార్ ఇన్వర్టర్ లో మనకి మెనీ టైప్ ఆఫ్ ఇన్వర్టర్స్ ఉన్నాయి. వాటిలో బెస్ట్ ఇన్వర్టర్ అంటే మీకు తెలిసిన దాంట్లో ఏంటి సార్? ఇప్పుడు డెల్టా, ఎస్ఎంఏ,
జనరల్ గా అట్లా చెప్పలేం. It depends
సన్గ్లో
on
అంటే
best
సన్గ్లో
inverter.
ఒకటి ఉంది.
Okay. See, best inverter defines so many parameters. Okay, it depends. Like
Yes, sir.
we cannot comment on it like this is good, this is bad.
మ్యానుఫ్యాక్చర్ మీద కమెంట్ అయితే చేయలేం సార్.
Because there are so
సార్
many
మేడం
parameters
మ్యానుఫ్యాక్చర్
involved.
మీద కాదు, అంటే ఇప్పుడు మీకు ప్రాక్టికల్ గా ఏంటంటే నెంబర్ ఆఫ్ స్టూడెంట్స్ ఉంటారు. వాళ్ళు ఏంటంటే మీ ఫీడ్బ్యాక్ వల్ల కూడా ఏంటంటే మేము వచ్చి ఒకసారి వర్క్ చేస్తాం. మీ దగ్గర అంటే ఇప్పుడు నాలుగు ఎంప్లాయీస్ కానీ స్టూడెంట్స్ కానీ ఓకేనా. ఇప్పుడు మేము ఉంది మేడం, మేము ఎస్ఎంఏ ఇన్వర్టర్ వాడుతున్నాం 25 kV, మాది 150 kV ప్లాంట్. ఇక్కడ వచ్చేసి కొంతమంది డెల్టా బాగుంది అన్నారు, కొంతమంది సన్గ్రో బాగుంది అంటున్నారు.
Okay.
ఎందుకంటే ఇలాంటప్పుడు ఏంటంటే మనకి మినిమం 600 to 700 మెంబర్స్ ఉన్నారు దిస్ పార్టిసిపేషన్. అది జస్ట్ ఫీడ్బ్యాక్ అనేది వాళ్ళకి తెలుసుకుందామని అడిగాను మేడం.
See, it depends on service and cost and performance. There are so many
క్లయింట్ కూడా
parameters
సార్, ఐ
involved.
మీన్ లైక్ సర్టన్ టైమ్స్ క్లయింట్ వాంట్ సర్టన్ స్పెషల్ ఫీచర్స్, సో ఆ
Yes,
బేస్డ్ కూడా
yes.
వి సెలెక్ట్
అంటే క్లయింట్ మేడం జనరల్ గా ఏంటంటే ఇప్పుడు మనకి వచ్చేసి ఇన్వెస్ట్మెంట్ అనేది హై కాబట్టి ప్రతి క్లయింట్ కూడా మాక్సిమం మంచి ఎఫిషియన్సీ లైక్ చేస్తారు.
Yeah.
డిపెండ్ ఆన్ ది
రాంబాబు గారు
మెయింటెనెన్స్, డిపెండ్ ఆన్ ది
యా సార్, యా మీరు ఒకసారి కావాలి అంటే మా వెబ్సైట్ నెంబర్ అయినా ఏ నెంబర్ కి చేసినా వి విల్ కాంటాక్ట్ యూ అండ్ టాక్ అండ్ క్లియర్ యువర్ క్వైరీస్ అండి. ప్లీజ్ డోంట్ మైండ్, విల్ కంటిన్యూ.
థ్యాంక్ యూ మ్యామ్. థ్యాంక్ యూ సార్. థ్యాంక్ యూ ఫర్
Thank you అండి. Thank you so
స్వామి
much.
గారు, యూ కెన్ అన్మ్యూట్ అండ్ స్పీక్ అప్.
గుడ్ ఈవినింగ్ అండి.
గుడ్ ఈవినింగ్
Hi,
సార్.
good evening.
గుడ్ ఈవినింగ్ సార్. ఇప్పుడు ఇంటర్న్షిప్ ప్రోగ్రామ్ లో చెప్పారండి, అందులో మనకు ఎలక్ట్రికల్ క్యాడ్, ప్యూర్లీ ఎలక్ట్రికల్ క్యాడ్ నేర్పుతారండి.
యా సార్, అంటే ఇప్పుడు ఈ ఇంటర్న్షిప్ ప్రోగ్రామ్ లో విల్ నాట్ హ్యావ్ ఎలక్ట్రికల్ క్యాడ్, బట్ యూ వాంట్ ఓన్లీ ఎలక్ట్రికల్ క్యాడ్ as an internship, we can do that.
ఓకేనండి, నాకు ప్యూర్లీ ఎలక్ట్రికల్ క్యాడ్ కావాలండి, రిలేటెడ్ టు సోలార్ అండ్ సింగిల్ లైన్ డయాగ్రామ్ ఫర్ హెచ్టి లైన్స్.
Electrical CAD with respect to solar, normally what we teach in terms of solar, we teach electrical CAD only, Andy. But you are
Okay.
talking about electrical CAD which designs schematic designs, wiring drawings
Yes,
చేస్తుంది.
yes.
సో అదికి దానికి
హెచ్టి
solar
నాట్ వైరింగ్ అండి, నా హెచ్డి డ్రాయింగ్స్,
HT
నాట్
drawing.
వైరింగ్స్, హెచ్డి డ్రాయింగ్స్, సింగిల్
Oh,
లైన్ హెచ్డి డ్రాయింగ్స్.
okay, that
For example,
AutoCAD is being taught in
government
this schematics, sir.
uh,
In
So
this
you
solar
please
internship.
contact us later. We will guide you
okay,
like how to how to take it further. Okay.
okay sir, okay sir, thank you.
Thank you,
Thank you
sir.
so
Thank you.
much.
Azam, you can speak up. Sheikh Azam. Okay. Yeah.
Sir.
Good evening, Sheikh Azam. Yes, please. Sorry if I'm spelling your name wrong.
Okay. Sir, can you explain the concept of the duck curve in relation to solar energy integration?
Sorry.
The duck curve in relation to solar energy integration. The concept of duck curve.
Ducko.
Duck curve.
Duck curve.
Duct curve. No, I'm not aware of that actually. What exactly you're asking about?
I heard somewhere, so that's why I asked the question, sir. Okay, sir. Thank you.
Generally, we don't know what is duct curve
Okay,
in
duck
solar.
curve is basically related to the generation aspect and all, Azam. That, but we are not completely into that aspect. So we will get back to you maybe we'll answer your question sooner. Thank you.
Okay, thank you, ma'am.
Thank you. Thanks, Aram, for the question. Sanket, you can unmute and speak up.
Hello, am I audible?
Yes, yes.
Sir, good evening, sir. Good evening, ma'am.
Good evening,
So,
Sanjay.
sir, I have two questions. First question was that about can you comment on that net metering when we connect the solar plant to the grid? So, what the net metering plays the role?
So you want to know like what is net metering and
Yes, yes.
net metering is very simple. Like whatever the net meter we connect in the solar plant, that will record how many units of power we are exporting and how many units of power we are importing from the grid. So that will be recorded in the net meter. It's a bi-directional meter. Generally, our meter, normal meter will be the single direction. It only records export, like importing. But as we are generating the solar power, so sometimes when your load is less than your generation, then remaining power will be exporting to the grid. So the number of units import and export will be recorded in the net meter. That is a net metering scheme. Thank you.
So
There is one more.
Sanket, you can unmute yourself and ask the question.
Yes, sir. So about the second question, that was about you already mentioned about that initial cost of the particular solar plant will be much higher. So for around 50 to 60,000. So about the lives of the solar plant, will it that amount can be retained from the production of energy from solar plant? So I mean, initially like we are investing that amount for in solar installation, so that amount are we getting recovered at the end moment?
Yes, of course. That will be recovered in hardly nowadays. Like it is taking 7 to 8 years of time because your total lifespan of the solar plant will be 25 years. So within 7 to 8 years, you will get back your investment. So the remaining years will be the profit you are getting from the plant.
Thank you, sir. Thank you,
Sir,
ma'am.
we'll take, thank you, Sanket.
Yeah, we will take.
We'll take one question from YouTube where is there any difference of summer and rainy season generation of power? After rainfall and the dust, impurities will be washed out from the module. How does the rainy season solar generation will be?
See, there will be definitely a difference when compares to rainy season. You will have good energy generation in summer, and compared like you were saying like about the soiling losses and all. So to avoid the soiling losses, every week or 15 days a week, generally people clean the modules. That's where you will not have any impact in the summer.
Right. Venkat Teja, please ask your question.
గుడ్ ఈవినింగ్ సార్.
Hi, good evening, Venkat.
సార్ ఇప్పుడు సోలార్ పీవీ డిజైనింగ్ లో మనకి ఇన్వర్టర్ గురించి కాన్సెప్ట్స్ కూడా ఉంటాయి కదా సార్. ఇప్పుడు ఇన్వర్టర్ డిజైనింగ్ కూడా చెప్తారా, ఇంక్లూడింగ్
చెప్తామండి.
సర్క్యూట్ డయాగ్రామ్స్?
Everything will be explained in detail in the internship.
అండ్ ఇన్వర్టర్ డిజైనింగ్ లో మనకి జాబ్ రోల్స్ ఏమేమి ఉంటాయి సార్?
సారీ,
ఇన్వర్టర్ డిజైన్ చేసుకుంటాం కదా సార్, పర్టికులర్ 24 volts బ్యాటరీకి కానీ 12 volts బ్యాటరీకి కానీ ఇన్వర్టర్ మనం డిజైన్ చేసుకుంటాం మ్యానుఫ్యాక్చరింగ్ కంపెనీస్ లో.
Generally, that is a charge controller. You are talking about 24 volts, 12 volts battery will be connected through the charge controller. That is for off-grid applications you are talking about. When it comes to on-grid, we use inverter. It's a different criteria, selection criteria and all will be the different.
Thanks, Teja. Right. We are done. There's a question from Shruti. Sir, we use battery for storage of electricity from solar plant. Then on what basis? How do we decide the capacity of battery rating? Maybe it needs long explanation, Shruti. So
Depends on your connected load, Amma.
That is one reason, and your backup required for the plant.
Backup also matters for your battery capacity.
Yes. Thank you, guys. Thank you for your patience. We thank Sridhar sir, who's not available right now, but thanks for his time even after his schedule, hectic schedule. Thank you, Madan sir, for your time, and we had great time in interaction.
Thank you.
Thank you so
Thank you,
much
guys. Thank you for your
to all
wonderful
the team
question.
and all the participants. Guys, see you all tomorrow with an exciting topic that is
Yeah,
solar
a
EV electric vehicle technology with the industry expert.
Yeah,
So
an
let's
immediate
connect some
takeaway
other.
from it. Sorry to interrupt you, sir. We have given you an internship which is starting on 16th September. If you register today, it will be of 2,000 rupees. The link is been shared on the chat box. And tomorrow we have EV session, right, guys? And we do have an job-oriented course training program on September 23rd starting, and then it'll be for 2 months. For more details, you can contact our team. Thank you so much. Have a good day. Good night.